Welcome everyone to our YouTube series, Test Prep Made Easy. So in this particular series, we are going to post regularly questions on our YouTube channel. The questions may pertain to CAT preparation, maybe pertaining to GMAT preparation, as well as of various topics which are tested in these particular exams. For example, quants, LRDI, English, and various areas which are tested. And each day we will handle certain number of questions and their video solutions. The best approach is to these questions in these videos. So have a happy preparation ahead and enjoy the video. Thank you. These are the 4 questions that we are going to try today, guys. Um, Starting in few seconds, we will be having the solutions one after the other. So if you want to try the questions yourself, we recommend you to pause the video at this point and try the questions once yourself before looking into the solutions of these questions. And if you just want to enjoy the video, then just go ahead and check the solutions now.
All right, we have a question on progression. So it says the infinite GP each term is equal to 3 times the sum of terms that follow. So every term is equal to 3 times the sum of the terms that follow. Indirectly, it is telling us that I mean, the common ratio has to be less than one or a fractional one. Because if the common ratio would have been greater than one, then in that case, we would have had, this thing can never be possible, right? So, I mean, the question directly doesn't tell us that, but okay. So the first term is equal to the, I mean, 3 times the second term onwards, all the terms sum. Similarly, every term is following the same pattern here. So if the first term of the series is 8, find the sum of the series. Great. So the only thing that's missing out here is to find the common ratio. Then we can use the summation of GP series for infinite terms idea. So we have the terms as 8, 8R, 8R square, 8R cube, and so on. So these are the terms here. And we can take any term here. So I'm just taking the first term. So first term is equal to 3 times the sum of the rest of the terms. Now, coincidentally, this also is a GP with the first term as 8R, and the common ratio is same. The common ratio is again R, and this is also an infinite term series. So effectively use the summation of infinite terms. So that is first term divided by 1 minus common ratio, and that should be equal to 8. So all we have to do is just solve for this. So we have something like 8 minus 8R is equal to 24R. So 32R is equal to 8, or 8 is R is equal to 1 by 4. So this is what we get, right? 8 by 32. Now, once you have got this, we need to find the sum of the entire series. So we have to add all of this to it. But so just utilize this idea. So what we have is 8 divided by 1 minus R, and the R is 1 by 4. So just substitute and you get the answer as 32 by 3. So that's what we have. Now, this is the technical way to solve this problem. I would like to explain another aspect into this. Forget about this entire thing that I did. So let me just take this entire thing off. I'll just rewrite the terms again. So the first term is 8. Then we have 8R. Then we have 8R square, 8R cube, and so on, right? Now, what we know is if I add all of these, so let's say in this case, I get a sum of S. So 8 is equal to 3S. This is what we have, right? Because 8 is equal to 3 times the sum of the rest of the term. So this is what we have. So implies that S is equal to 8 by 3. So this is what we have obtained. Now the question is looking for sum of all the terms. So now the sum of all the terms is including this 8 as well. So the requirement or the required uh, sum is basically 8 plus this S, right? Because that is the sum of the rest of the terms. And we know S is 8 by 3, so effectively it is 8 plus 8 by 3. Again, you can just solve this and you get the answer as 32 by 3. So this is another method without finding the common ratio. If you are good with fractions, then this part, I don't think you have to use this variable as well. Because if this is 8 and you understand this idea, so this entire thing will be one third of 8. So all you're doing is adding 8 to one third of 8. And whenever you're adding any number to one third of itself, you should effectively have four-third of the number. So that is 32 by 3. So this actually you can do it mentally itself. Hardly it will take you 15 seconds if you understand this idea quickly. So interesting problem. I wanted to discuss two methods here. If this idea doesn't click, then you can effectively solve it using the basic itself. But this is just an analytical point of view. If you understand this, this is a very nice question to try. So that's it for this problem. Thank you. Okay, so we have to find the range of this function. Whenever you're looking for range of any function, always try to simplify the function itself if possible. That will automatically help you to, get the answer quickly. So the first thing you should be able to notice is if you take a 2 common from the denominator, you'll again have x minus 2, but that will be inside the mod, but that's not a worry. But if you do take the 2 common, you will have an x minus 2 as a factor, right? So let me just rewrite this as something like this. Now, whenever we do these kind of operations in algebra, even when you're looking at solutions in any book or mocks or anywhere, always try to understand why this can be done. So, for example, in this case, I just took this two outside. Whether this is possible or not, it's inside a mod, right? It is possible because this two is a positive number. So what I cannot do is, so for example, let me explain this using an example. If I have something like this, I cannot take a minus 2 common and write this as something like this. I mean, you can you might think in this way, provided you have something like this. I mean, it's the same thing. So suppose you imagine it in this way, and then you think that okay, let me take the minus 2 common. So if you take this minus 2 common, now, this thing is going to be incorrect. That is not possible because what you have to understand is mod of x minus 2 will always be non-negative. And if you multiply a minus 2 to that, you're going to get a negative value. Now, originally you had a whole mod, and the whole mod can never return a negative, output. So you cannot have this as the answer. So this is incorrect, basically. In this case, if you take the minus 2 out, it will come out as 2 because it's inside a mod. So what we are indirectly doing is something like this. Mod of x into y is equal to mod x into mod y. I mean, this will always happen. This happens for every term. That is never a problem. Only thing you have to be careful is where you have plus or minus or something like that. But mod of x into y is always equal to mod x into mod y for real numbers. So effectively, what you can do is you can break it as something like this, and now you will not make a mistake. So this will also be something like this. So effectively, I just wanted to point out a common mistake at this stage. But anyhow, the question is pretty straightforward. uh, After you reach this step, you have something like half multiplied with, let me use this bracket, x minus 2 divided by mod of x minus 2. Now whenever you have this function, this type of function, anything, I mean, mod of let's say 3x square plus 4x plus let's say and 10 or something like this, divided by mod of 3x square plus 4x plus 10. I mean, it could be anything. I mean, all you have to do is check that this entire expression is in the denominator. So it's like mod of or a value divided by mod of that value, right? So whenever you have a function like this, it can return only two values. It could either return a 1 or a minus 1. I mean, you can do this algebraically or you can do this using common sense. So suppose I input a as 5. So if I put a as 5, so this expression becomes 5 divided by mod of 5. But mod of 5 is 5, so 5 by 5 will be 1. So that will be the output. But if I put, let's say, a is equal to minus 5, so in that case, the numerator will be minus 5, and the denominator will be mod of minus 5, which will be 5, right? So minus 5 by 5 is minus 1. So effectively, I mean, what I mean to say is, I mean, forget about what the a is. So this entire thing can be 5, right? In this case also, this entire thing can be 5. So if this entire thing, the x minus 2 is 5, then mod of x minus 2 is also 5. So 5 by 5 is 1. But if mod of x minus, or rather x minus 2 is minus 5, in that case, mod of x minus 2 is 5, and minus 5 divided by 5 will be minus 1. So same thing. So it really doesn't matter what we have, as soon as you see that, okay, there is the same expression in the numerator and denominator, and one of which has a mod. I mean, it doesn't matter which one has the mod. It could also be something like mod of x minus 2 upon x minus 2. So it's the same thing. I mean, you can only have the output as plus 1 or minus 1. Obviously, in this case, there is a value which is non-acceptable. That is for which the x minus 2 becomes 0, because 0 by 0 is undefined. So that will always be mentioned in the question itself. So if you look at the question, it's already mentioning x is not equal to 2. So that we are basically taking 2 out of the domain. So if x is never 2, then this cannot be 0 by 0. For every other value, it will always be out giving us an output of 1 or minus 1, typically what we look for in the range, right? So let's get the answer now. So what we have understood so far is that this part will give us an output of 1 or minus 1. In turn, the entire function will be half into 1 or half into minus 1, right? So there are two possible outputs, or that will be the range of this entire function, which is plus half or minus half. So that is option 4, which is plus minus 0.5. So that's it about this question. It's a pretty easy question. You just have to identify this. You have this expression mod a by mod a, something like that. And whatever extra is there, just multiply to give us the actual range of the given function. So that's it for this problem. I hope everything was understood. Thank you. Okay, so we have something related to parallel lines. If you have an understanding of parallel lines and how the equations indicate that, effectively, a parallel line is nothing but, okay, maybe the slope will be negative. Just don't take it out as it is drawn. I've just drawn a rough value. So you have root 3x plus the root 2y is equal to 6. And in this case, you have root 2x plus k of y is equal to 2. Now, parallel line means that these two lines will never intersect on a plane surface, right? So if they are not intersecting, you will never have a common solution, which or rather there will not be a particular solution of x comma y, a particular point which is going to satisfy both the lines. So that is never going to happen, right? So in these cases, I mean, what we tend to do is, I mean, this is something I've elaborated in the classes why. So it's very easy to understand any which way. But what we typically do is we check the coefficient ratios of x, y, and the constant term. So in this case, the coefficient ratio of x, the coefficient ratio of y should be equal, and that should not be equal to the coefficient ratio of the constant term. Then only that will be indicating parallel lines. So for example, in this case, the coefficient ratio of x is root 3 upon root 2. The coefficient ratio of y is root 2 upon this k, which is what we are looking for. And the coefficient ratio of the constant term, or rather the constant terms, are in the ratio 6 by 2. Now, this value and this value, you can directly say see that they are not equal, right? Root 3 by root 2 is not equal to 6 by 2. 6 by 2 is 3. This is an irrational number. So effectively, this two cannot be equal any which way. So don't concern yourself with this. Just make these two equal, because if you're making these two equal and this can never be equal to this, so in that case, root 2 by k will also be not equal to 6 by 2. So just make these two equal. That's all you need to do. So implying that k will be equal to root 2 into root 2, that is 2 divided by root 3. So that is option 2 here. That's all about this question. Hopefully this was understood. Thank you. We have a interesting question on log. Now, this requires a property to be used related to log. When I say a property to be used, I mean basic properties are typically known by most of the people, but there are certain specific properties which sometimes are useful in certain questions. Otherwise, it will be very lengthy to solve in an exam environment. Using the same property, we had an exact question in CAT 2019, I believe, which had, I mean, where you, if you use this property, it will be very, very fast to solve. So I'll just mention the property once. I have discussed this in our lessons. So it's something like this: a raised to log of b, base being whatever, it doesn't matter. In this case, no base is mentioned, so base is 10. Uh, is always equal to b raised to log of a. Again, the base should be same. So we can just interchange this a and b. It really doesn't matter. This will remain equal. I'm not going into the reasoning behind that. That will take a bit of time. In our lessons, I've done that. So this is a property which you can remember. It's sometimes very handy. For example, in this question. So the first thing I'm noticing when I'm looking at this question is the left hand side that we have is 81 log x. I mean, sorry, my bad, 81 raised to log x. And this thing is 2 times of x raised to log 9. So I'm focusing on this 81 raised to log x and x raised to log of 9. The thing is, I can represent both of these in terms of 9 raised to log x, because using this property, sorry for that, this property here, I can directly indicate this as 9 raised to log of x, right? So this is equal. And this thing, this is 9 square, isn't it? So we have something like this. Now, whenever you have that a raised to b into c, something like this, indices, so that can be represented as a raised to b whole raised to c, or a raised to c whole raised to b. It really doesn't matter. The powers get multiplied, right, to get this. So effectively, I'm using this idea of indices here. So what we can do is we can write this as 9 raised to log x whole squared, right? Because this is something like 2 into log x. So I can do that. So we can actually multiply this these two things. So now this simplifies a bit, because what I can do is I can express the entire thing in terms of this 9 raised to log x. So I'm just indicating this by some a. So let me keep this information here. And now let me write the equation in terms of a. So the left hand side is this identity, 81 to the power log x. So which is nothing but 9 raised to log x whole square, and that is a square. So left hand side is a square. The right hand side 1 3 you have, that is as it is, leave it as it is. And x raised to log 9 is basically 9 raised to log x, right? So this part is 9 raised to log x, so that is a. So what we have is 2a, right? So this is what we have, the simplified expression. So this is simply a quadratic, right? So we have something like a square minus 2a minus 3 equal to 0. Just solve for the roots. You get a is equal to 3 or minus 1. So this is the two things that we get, right? Two roots of the above quadratic equation. Sum of the roots is 2 and the product of the root is minus 3. Now, once we have obtained this, so we're looking for real values of x, right? How many real values of x are there? So we don't need to find the value of x, but how many real solutions of x are possible? One thing you should be able to understand, when log x is a real number, so x being a real number, log x is a real number. Log x being whatever real number, whether it is positive or negative or fraction, whatever it is, 9 raised to anything can never be a negative quantity. So it always has to be positive. Even if it's an irrational, that is fine. I mean, 9 raised to log x, uh, it could be equal to 5. That is fine for some irrational value of log x. But you cannot have the output as minus 1. So this thing, because By the way, this is a, right? So this is the solution we are getting for 9 raised to log x. So 9 raised to log x could be 3. This is feasible. But 9 raised to log x cannot be equal to -1. This is never possible. So we can discard that solution. So this is not a possible solution. And here we are going to get one real solution of x, right? So we are not interested to find the solution for x, but we're interested to find how many real solutions of x are there. So in this case, we are going to get one solution. So that will be the answer. Let me just quickly solve this. If the question had been asking for the solution of x, so in that case, how would you have approached from here on? I mean, there are a lot of ways you can do this. You can write this as again 3 square, or what I'll do is I'll just simply take both as powers of 9. So the left hand side is already a power of 9. So let me leave that. And 3 is basically square root of 9, right? So that is 9 raised to half. So this is what we have. So effectively what we have is something like this. Log x is equal to half. Now use a very basic of log. By the way, if no base is mentioned, the base is 10. So this is something like log x base 10 is half. Let me just write this a bit properly. So this is what we have effectively, which implies that x is equal to 10 to the power half or root 10. So this is the solution of x. I hope everybody is aware of this. I have discussed this in our lessons. Log and indices has this relationship between themselves. Whenever you have log uh, n raised or n to the base b is equal to p, effectively what it means is this b raised to this power p will give us n. So this is the basic relationship between logs and indices. So that is what we have done here. So log x base 10, it implies that x is equal to 10 to the power this thing, whatever this is. So there is 10 to the power half, or which is root 10. I've written root 10 here, by the way, if that is not legible. Yeah. So let me just write this again. So x is equal to root 10. Yeah, so but as I said earlier, I don't have to solve this. The question is looking for how many real values, so we could have stopped at that point. But I just wanted to give you that solution as well. We can have that question in CAT as well. So find the value of x which satisfies the given equation, and you will have root 10 in the option. Anyhow, that's the solution for this particular question. Hopefully everything was understood. Thank you.
Hopefully you liked the solutions we provided for these questions. And if you did like it, do not forget to like the video and share, subscribe, and comment. Do subscribe to the channel and click on the bell icon. In that case, you'll get notification as soon as we upload a new video. And if you want to check a bouquet of courses that we provide, so we have a huge variant of courses from customizability to full preparation. You can check our website www.mathoratory.com. I'll leave the link in the description below. And have an enjoyable preparation ahead. Welcome to the Mathoratory family and have a good exam ahead.